have this mass number. Okay. Mass number is not the mass, really. If you say mass number, it's not the same as mass. The mass, the unit is gram, kilogram, but the mass number referring only to the, to the nucleus of the atom, not the weight or the mass, something like that. You get the point? That's what we mean here, okay? Not the other mass that we mean, the how weightful ba? Okay. Weight ba siya? So weightful, adjective, right? How heavy, how light, ganon. Diba? So mass number, tama ba ang English ko, guys? Okay, mass number, and then electrons. Electrons are the center of the study of electrical engineering and electronics and communication engineering. Okay, so they should have knowledge, adequate knowledge of what is an electrons all about. Okay, the electricity will be always dealing with that. The basic foundation of their course is the electrons. Okay, are the electrons. And it's very clear, right? Electronics, from the word electron. And they're very lucky because they're only focusing more on the electron. Okay, but chemical engineering are focusing all the molecules, the elementary particles. Very difficult, really, guys. Okay, we will just imagine everything in our study. We will imagine what will be happening in the nuclear chemical reaction, like that, and so we cannot really see everything what's going on. That made difficult to understand. Always having a wild imagination like that, because normally some of our study we can never see on our eyes. Okay, especially the behavior of, for example, the Bohr model theory, something like that, and you can never see the smallest particle, something like that. Okay, and you can never see also the photon particles on the light emitted during it will release light. So we can never see the photon particle, right? But we study that a lot in the radiant light energy. Ganon. So very difficult. Okay, but carry lang siya. Charot! So, proton. Okay. Mag-focus you can carry my course. Okay. So we have proton, neutron, electron. We will not study the nuclear, nuclear elementary particles. Katong mga grabe na dito, itong mga positron, okay, mesons, baryons, like that. There's a lot, guys. Elementary particles, there's also sub-elementary particles like that. And after sub-elementary particles like this, and then protein yung gamay ang tiniest particles that you can never see in your naked eye, or you cannot see only in the microscope, some technology, something like that. Okay, so especially the behavior of the living microorganisms. So almost invisible. It's really invisible because you cannot see there in our eyes, right? Okay, so electrons. Okay, ganon and charge. What's the time now? Charot! Okay, so I will draw the atomic structure. Okay, discovered by John Dalton atomic theory, so that we can really understand what's going on, and we will be using also the Bohr model theory, BOHR, by Niels Bohr, a scientist. Right? And there's a lot of outermost shell and the orbital, something like that. SPDF orbital, ganon! Ito mga principal quantum number, energy levels, o diba? Okay, magnetic spin, ganon! Okay, tungal sa akong brain size. Okay? Ninumduman na ako, guys. Okay, so we have like this, and if we study this Guys, we normally relate this to the electronic configuration of elements. Electronic configuration of the elements. I've told you a while ago, S, P, D, F, and this S contains maximum number of electrons of how many? Like that, and this P contains maximum of electrons of how many also, and there's a formula of, I think, so 2n squared. Okay, and the n is the number of electrons as far as I could remember. Like that, okay? But we'll never touch that. That's another topic. We will focus on that here, okay? So for example, guys, I have this atomic structure like that, circle, okay? And another circle in the center. So we have now energy level 1, energy level 2, like that. So we normally treat that as energy level as small letter n. So n is equals to 1 because this is energy level in the first, and then n is equals to energy level at the 2, second, something like that. And then guys, this is outermost shell also, the energy level. And then the electrons, guys, will rotate here. Electrons. Rotate, the electrons will be here. All the negatively charged particle, which is the electron, is always rotating here in the energy level because for the reason that it is light gaan compared to protons and neutrons. That's why he will be on the outside, not on the center of the nucleus. Now, neutrons and protons are just like a couple, okay, like that boyfriend or girlfriend, because they are banded together at the center of the nucleus. Here, okay, so protons and neutrons, ganon. Here is the electrons, like this, like this, like this, like this, like this, like this. Ganon. Now, so we can say electron is very light. Okay? Like that. And if we talk about the mass of an electron based on my memorization, that is 9.11 times 10 raised to the power negative 31 kilogram. Okay, because I memorized this when I was in first year college. Okay, and then what I remember, guys, the exponent are huge. And then the exponent also are negative, something like that. So that's why it always reflects in my brain cells because I always take note that the exponent is huge and it's negative. Something like, and the unit is in kilogram. And then I also have the clue that something of 9.11 like this. Okay, actually 9.1066 and then it's round off man siya. And then the proton, guys, I don't memorize this exactly one by one, but in the theory, more or less nearly the same with each other. It's gonna be 1.67 blah 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 so and so times 10 raised to the power negative 27 kilogram, if I'm not mistaken. Okay, so there are always have the same unit, positive. Okay, something like that. You get the point. Okay, it doesn't mean that the electrons are negatively charged particles. You will also put negative in the 9.11. It's not because we mean of mass nandun siya, not the charge. The charge thing is another issue. Charge. Okay, the charge like a valence. Okay, the valence in the outermost shell, something like, or the charge, something like that. Now we will refer that to the column or the what we call as the period. Yeah, period is the column. The row is the family, something like that in periodic table. Okay. So the column would represent the valence. Okay, the valence and the charge. For example, if it's in the column 1, like this, katong mga sodium, di ba? Ang nag-una sa taas kay hydrogen, nanti sodium, magnesium ba to? Sunod dito. Okay, yung ana, potassium, strontium, ganun. Sunod kay manganese, okay, tsaka calcium, magnesium, ganun. So 2, okay, because naman siya sa column 2. So the column would represent the charge also and the valence. Okay, that's very important because during the banding, chuba chucho, you will put the dot, right? So you can easily have the covalent banding like that, ionic banding, or name it, okay, or hydrogen banding, van der Waals banding, or the dipole, any kinds of banding you want, okay? Not limited only to covalent, but covalent is more popular, right? Okay, so we have this. Okay, now the formula of mass number. Actually, I have 8. Okay, I have 8. Actually, if you memorize only, I think 3, by using algebra alone, you can establish 8 formulas. Okay, but in my case before, I will just memorize minimum, and I will be the one to transpose, chuba, chucho. You get the point? But for the purpose of convenience, I found out that it's better to memorize talaga siya. 8 formulas rather than memorizing the minimum. So that you will never transpose, siya, whatever. In algebra, right? If it's in the left, you transpose, it will become negative. If it's in the right, it will become positive. Like that, even though you have only 2, you can play around the transpose of your formulas. For example, mass number, ganon, is equals to the number of protons plus the number of neutrons. Okay? So for the number of neutrons, ganon. So number of neutrons is equals to the mass number minus proton, like that. Okay? And then if you try also to compute with the proton, so proton is equals to the mass number minus neutron, like that. Even though there's only one, you can play around, you can get 3 equations or formulas for this. Okay? Something like that. You get the point? Okay. For example, I have an example, the element known as lithium. Lithium, I think so. Lithium, I think so. Under siya sa padung sa transition. Wait. Okay, lithium is, just double check also because that was 20 years ago. Okay, I did not review also. Okay? My gosh, nabasa rin ko sa akong stock knowledge. Okay, so lithium. So it's gonna be, I think so, in a way, the principle is just the same. Even though you will put anything there, hypothetical, but if in reality, you will see the periodic table, so the principle will apply. It doesn't matter, right? Okay? Get the point? So let's say 7, 3. Okay, 7, 3, mass number, 3 is the number of proton. Okay? Number of proton, ganon. Okay? 7, nabuang man yun, hindi mo maklaro. Ay nako, 7 and 3. Okay guys, in the upper portion, that is the mass number. I don't have the table also, so that can show you, right? Basta, in the upper portion is the mass number. So I'll just put Mn. So this is not manganese, the symbol of manganese is capital M, small letter M. It's only mass number. Okay, I just put a copy so what guys. Okay, so mass number. And 3 is the number of protons. So I just put P. And take note guys, automatically and technically the number of proton is our atomic number. So proton is also equal to atomic number En. Okay. Now, so if I would say that the mass number is equal to the number of protons plus neutrons, so I can say also that the mass number is equal to the atomic number plus neutron. So we have the equation 1, equation 2, by using the mass number. Okay. Now, we will use now the proton. Okay, the proton. So the proton will now be equal to the mass number minus the neutron. See? By algebra. Transpose manganese. Sorry. Mass number minus n. Okay? Ganon. Ano siya ang proton, guys? Okay. Number of protons plus neutrons. Okay. So, nanakay protons. Okay. Got the point? Now, you can say also atomic number, because proton and atomic number is just equal nun siya. Atomic number is equals to mass number minus the neutrons. Right? So, equation 3, equation 4. Okay. Ganon. And now, how can we compute for the neutrons? Okay, so neutrons are so neutrons is equals to the mass number. Neutrons is equals to the mass number minus proton. Equation 5. Now we can see also neutron is equals to mass number minus atomic number is equals to equation 6. So nanatay two equation formulas of mass number, two formulas of neutrons, and one formula of proton, and one formula of the atomic number. So how many? 1, 2, 3, 4, 5, 6. Now guys, there's another formula also. This is very important, guys. And this is not clearly discussed in, it's not fault of the teacher also, because we should also find an initiative to do that by ourselves, right? To be responsible enough with our studies. So the only one can save us is ourselves. Okay? Even though because some teachers cannot also feed us everything. Okay, so this kind of formulas are not really that familiar, but when you go to higher examination, it will come out. So this is all about the charge. Okay, so charge. What is the formula of the charge? The formula of the charge, if you nominate a charge where it belongs to the column, for example, in 2, 3, this is automatically the charge, something like that, or the valence. So the charge will be equal to the protons plus electrons. Okay? Proton, equation 7 na. Okay? Charge is equals to protons plus electrons. Now, since proton is equals to atomic number, then technically charge is equals to atomic number plus electron. How many equations you have now? 7 and 8. I told you 8 before, right? But there's still 2, guys. If you try to solve for electrons also, sorry. Okay, so electrons. Okay, electrons is equal to the proton minus the charge. Okay? Okay, like this. By this, see, electrons is equals to, like this, see? Computing this charge minus the proton, something like that, right? In this equation number 7, you can derive the electrons. You get the point? So, electrons is equal to transpose. Ganon. So, charge minus proton. So, electrons is equal to charge minus proton. Then, electrons also is equal to charge minus atomic number. So, there are 10 equations. There are 10 formulas to be used in this topic. If you try to compute the element. What are the charges, mass numbers, electrons. So imagine there are 10. But you will just choose the basic because you will need to use the algebraic linear expression na lang siya to transpose to get what is being asked. Okay, malibog man punta. Okay, but for me, I would rather memorize everything, the 10. Okay, like that. Because I love memorization. Okay, like this. Okay, we have now 10 equations, right? And now we need to solve this actual. Okay, for the lithium. Calculate the number of neutrons of lithium. Oh, ganon. So, so neutrons is equals to the mass number. Neutrons is equals to the mass number 7. Okay, minus the atomic number. Right? Okay, ano siya? Mass number is equals to neutrons plus proton. Okay, so neutrons equals to the mass number minus the proton. Mass number is 7 and the proton atomic number is 3, 4. Neutrons is 4. Okay, neutron is equal to 4. Okay, now calculate the number of electrons. Okay, how can you do that? So we have the charge is equals to proton plus the electrons. The electrons is equals to charge minus the atomic number. So take note the charge. You will get now the periodic table. Okay, get the point. You get now the periodic table so that you can have the charge and then bingo, you can calculate the number of electrons. Because the only given is the proton and the manganese. Okay guys? Thank you so much for listening for this vlog all about the element. Thank you so much. You can like, comment, and share this vlog, and you can subscribe my YT channel, and then you can click notification bell for some news after 7. Sing your channel voice. Bye bye, God bless everybody. Hi. Jumbo dan bumbo